Here we have a situation where we're going to actually determine how many subatomic particles are in an atom. Our two examples here are chlorine-35 and chlorine-37, two isotopes of chlorine that have different masses. So the first thing that we're going to do, since the number here identifies what the mass number is of the atom, let's symbolize the isotopes correctly. Chlorine, the symbol is Cl. Mass number always goes in the upper left, and in the bottom left we have the atomic number, which we get by looking on the periodic chart, is 17. So to determine how many protons, neutrons, and electrons are inside this isotope, well, the first thing that we're going to do is pretty easy. We're going to look at the atomic number, and that always determines the number of protons. The number of protons identifies the element. Another thing that's rather simple, in a neutral atom, which for now we are working with, the number of protons will always equal the number of electrons, because protons are positive in charge and electrons are negative in charge, and these values must be equal to each other in order to balance out and make the atom neutral. Now the other subatomic particle we still have to determine how many particles are there would be the neutron. Now this is also a pretty simple game. Protons and neutrons make up the mass of the atom, and it's these two particles that will make up that mass number of 35. So obviously 17 plus 18 will equal the mass of the atom, 35. Chlorine-37. The symbol for chlorine is Cl. The mass number is 37, and the atomic number is 17, which we get by looking at the periodic table. The number of protons, neutrons, and electrons can be found by looking at this information given to us. The atomic number, which is written in the bottom left, again is always equal to the number of protons. And since protons are positive, that must equal the number of negative particles inside this atom for a neutral atom. To determine the number of neutrons, we will take the mass number 37 and look at our protons and neutrons. The sums of these two particles must add up to the mass of the atom. So 17 is how many protons we have, and therefore the number of neutrons that there must be is 20.